Hi learners, welcome back to our class. We are talking about the weight relationships of soil, and let's get to it. So we want to see how do these soil properties relate in terms of weight. So we talk specifically on bulk unit weight of solids, unit weight of water, and saturated unit weight. You can pause the video and think of them, what you think they are before we get to it. Okay, that's great. So bulk unit weight is defined as the weight per unit volume of the soil mass. So how can we represent that in our phase diagram? We can see that it is the total weight per unit total volume. So it is weight divided by volume. So you realize, and when we talk of weight is given by the weight of solids plus the weight of water plus the weight of air, which however the weight of air is usually taken as negligible. It is taken as negligible. So we can also say that weight is given by the weight of solids plus the weight of water. What about volume? Volume is given by the volume of solids plus the volume of water plus the volume of air, as you can see from the phase diagram. So bulk unit weight is the weight per volume of the soil mass. That's great. What about the unit weight of solids? The unit weight of solids is taken as the weight of solids per unit volume of solids alone. So unlike bulk unit weight, which we considered the total weight and the total volume, the unit weight of solids, we only consider the weight of the solid particles, as you can see in the phase diagram. So and it is denoted by gamma S. I forgot to mention that in the previous topic. This is gamma. It's denoted by symbol gamma. So this is bulk unit weight. Unit weight is given by weight over volume. Unit weight of solids also, it is the weight of solids to the volume of solids alone. Okay, so it's the volume of solids and the weight of solids. Yeah, these are the parameters that we'll use even when you're talking about more things to come, such as dry density, compaction, optimum moisture content. We'll use these parameters to achieve, to obtain them. So the unit weight of water, taking the same procedure clearly, the unit weight of water is the weight of water per unit volume of water alone, denoted by gamma Y. So this is, we are only talking about water. So it will be the weight of water to the volume of water. Weight of water, volume of water alone. So in ideal conditions, the unit weight of water is usually taken as 9.81 kilonewtons per meters cubed in ideal conditions. Yeah, that's great. That's great. What about the saturated unit weight of water? And we said that it is saturated. If it is saturated, it means the voids are filled with water. We also mean that there is no air. So when we talk of saturated, the total volume is given by the volume of solids plus the volume of water. Because as you can see in this diagram, this is a fully saturated soil that has no air. It only has water and the solids. So the total volume is given by the volume of solids plus the volume of water. And the total weight is given by the weight of solids plus the weight of water. So you'll realize that when we talk of saturated unit weight, we're saying the gamma saturated is given by the weight all over the volume, and this volume is only the volume of solids plus the volume of water because it has no air. So that's great. I think I can talk about dry unit weight. Dry unit weight, so this is dry soil in its condition. In its condition. So we are talking about the unit weight of a soil mass without, that has only air. That has only air. So it is dry. It has no water. So yeah, thank you so much for listening. I'll see you again in the next video. Bye bye.